Well, hello there, boys and girls. Glad to have you back here in physics. Today we're going to be doing some work over these practice problems. What you're going to learn today is we're going to learn the importance of creating a list, and we're going to learn ways to decode story problems. What you'll find out is as your reading skills improve, your physics scores will improve because it's really going to, most of the math, almost all of the math. It's really going to come down to your reading skills. All right, in this problem, um, what is the average acceleration of this object? I noticed that I've misspelled acceleration, but we'll continue on at this point. Well, the acceleration um, is, as we've learned, is the slope of this line, is the slope of the best fit line. And the slope is given to us here in our equation. So one way we could find it is by looking at our equation, and we would say that it's approximately 1.89 meters per second squared. Another way we can go about this is to actually calculate it by finding the slope manually. Well, that's what I'm going to do here to start off with, just so we get a little practice at it. I'm going to say that this ordered pair right here is 1, 3. And the next one I see that's really easy, this is really close, and I'm going to say that's 6, 12. So, to find the slope of this is I'm going to take 12 minus 3 and then 6 minus 1, and that gives me an answer of 9 over 5, which gives me an answer of 1.8 meters per second squared. So you can see by doing it by hand, roughly, we're going to get approximately the same answer here. The next one. What is the acceleration of the object between 5 and 6 seconds? Well, that would be approximately right here in the middle. This would be 5. And because it's on this same line that I just found the slope for, I would say that the acceleration between 5 and 6 seconds would still be 1.89 meters per second squared, or 1.8 meters per second squared. Now I'm going to admit I made a mistake here. Probably should have deleted that question, but for all rights and purposes we're okay with that. Tell whether the accelerations are negative, positive, or zero. Well, what is the slope of this line right now? What is the slope of this line? Well, as we look at it, it's going up, and we would say right now that this object in general, whatever it is, for the most part is increasing in speed. So it's a positive slope. The acceleration then is positive because the acceleration is the slope of the line. The last one here is asking us to find the displacement. The displacement between 2 and 4 seconds. Well, I'm getting rid of all these other points that we have on here. And if we go about finding the displacement is the distance that it's traveled. Well, that's the area here underneath this. As I look at this, I'm going to say that this can be found, I'm going to draw that top triangle a little bit better. And we're going to guesstimate here a little bit, but this bottom square or rectangle has a length of 2, a base of 2, and it has a height of, it goes up here to 5, so it has a height of 5. 2 times 5 gives me an area of 10, so that means the displacement here was 10 meters. And then I have this triangle up on top. Again, it has a base of 2, and its height is from 5 up to approximately, I'm going to say 8, so it has a height of 3. Now once again, I'm using estimates to give us a rough idea, but that would be 2 times 3, which is 6. Half of a triangle is 3, so this right here has a displacement of 3 meters. So our total displacement between these places is 13 meters. Alright, you're designing a testing facility of A.J. Foyt. One kind of dragster he is producing must reach a speed of 110 meters per second and can accelerate at 25 meters per second squared. If the drag strip is 100 meters long, can this dragster reach 110 meters per second? Now what I've done here is I've went ahead and wrote in 3 of our 4 kinematic equations. I'm not going to include the 4th one because, like I said, you'll seldom ever use it. So we won't talk much about it. In this case, the information. I'm going to make a list here to start off with. I know that it's a dragster, so its initial speed is going to be 0 meters per second. Its final speed, they tell us, has to be 110 meters per second. And it can accelerate at 25 meters per second squared. They give me that the total displacement, the distance that we have that we're going to go from our beginning to our final, is 100 meters. So I ask myself, can this dragster reach 110 meters per second? Well, this is the information they've given me, and they do not give me a time. So right away, as I look over here to the left, this first equation has to use time. The last equation has to use time. There's no way for me to use those two equations. So I'm going to choose my middle one here because it gives me places for velocities, acceleration, and distance. What I'm going to do is I'm going to basically, I have to leave something out that they've given me. What I'm going to do is I'm going to leave this final velocity out. And I'm going to say, I'm going to use this equation over here, and I'm going to simply say, given the initial velocity, the acceleration, and the distance, can I achieve this final speed of 110 meters per second? So, okay, what I've done here is I've went ahead and worked through this. I put 0. Sorry about that. I put 0 in for the initial velocity. I put 2 in where it is. I've put the acceleration as 25, and the displacement we're going to have here is 100 meters. When you multiply that, you're going to get the final velocity squared equals 5,000. When you square root both sides, you get a final velocity of 70.7 meters per second. So what does this tell us? Well, what that tells me is that given this acceleration, there's no way for us to reach a speed of 110 meters per second. So this testing facility at this point is not going to work. All right, we have the same question. It says, if not, what is the minimum, I've got that misspelled as well, length it must be? Well, I'm going to write my equations up here. Okay, I've provided our kinematic equations. Again, I haven't done anything with the last one that we don't really use. I see down here at the bottom I left 1/2 out, so I'm going to fix that. Okay, again, as I read this, I'm going to create that list because the list really allows me to work with the numbers and not have to read it. But if you're not making a list, you're always having to go back and decode and find information. It's a dragster, so its initial speed is 0. It tells me that the final speed I want to get to is 110 meters per second. The acceleration is 25 meters per second squared, and the displacement is we don't know. We're going to have to change this, we said. So as I look at this, I'm going to go back into this same equation because, again, I do not have time. So these two equations are out the window. In this case, I want to find x. It's the only unknown in this equation. So I'm going to plug in everything and then solve for the x. What does this new length have to be? So we're going to get 110 squared equals the initial velocity, which is 0 squared. You're going to learn to love zeros, plus 2 times 25, and then what does this new length have to be? Okay, what I've done here is I've went ahead and worked this out. I squared 110, got 12,100. 2 times 25 gave me 50. So I divided both sides by 50, and I find out that the length of this drag strip has to be 242 meters. So if I want to reach a speed of 110 meters per second, and I can only accelerate at 25 meters per second squared, then what we found out is the length has to be 242 meters for us to get to that speed. Well, I hope this helps some. The main things I want you to know is it's important to make your list. The list allows you to then disassociate from the story problem so that you're not continuously going back up and have to reread it. It'll save you much time if you'll take 30 seconds at the beginning and make a list. The other thing I would advise you to do is to write your kinematic equations down. Do not become just a calculator button pusher, because you never learn the kinematic equations and it's going to become a struggle for you. I would continuously be writing these down each time, and eventually what you'll find out is you'll start to learn them and you won't need to look them up. As long as you've got to keep looking them up, you're going to continue to struggle. When you start to know these off the top of your head, some of the connections are going to start to happen, and it's going to become much easier for you. Well, hey, I hope that helps you some. We'll be working on this again when I get you back in class. I'll see you on the flip side.